This chapter is going to involve several different variables that you're going to need to be familiar with. So the first one is temperature, and the official definition of temperature is the average kinetic energy, and that's a good definition that you should memorize. It's only 3 words long. And kinetic just means motion. So basically we're talking about the motion of the particles. The faster they move, the higher the temperature is. Standard temperature is 0 degrees Celsius. And you don't need to memorize that, it's in your reference packet. The units that we use for that in this class, we'll use Celsius a lot, because that's what our thermometers are. But for this particular chapter, you'll have to convert it to Kelvin, and I'll show you why in just a little bit. And then Fahrenheit is what the United States uses, but we don't really use that in science. Absolute zero is the point at which kinetic energy equals 0, so all the motion of the particles stop. And we actually have never been able to achieve this. Scientists are not able to reach absolute zero. No matter what they do, they can't get the particles to completely slow down and stop. They can get them to slow down, but they can't get the particles to completely stop moving. So we can get close to absolute zero, but we haven't actually gotten there before. And this is the conversion for how you get from Celsius to Kelvin. All you have to do is add 273 to the Celsius temperature. And this equation is in your reference packet as well. So here's a picture just to give you a visualization. Notice that the cooler particles are moving slower and the hotter ones are moving faster. The next vocab word is pressure. And here's the official definition. It's the force exerted by a gas per unit surface area of an object. What that means in my own words is that it's how often the particles collide with the container. So if you picture this container, the more often these particles hit the walls, the higher the pressure is going to be. If you have no particles, like say in a vacuum, then you would have no pressure because you would have no collisions with the walls of the container. I'm going to go kind of fast through some of this because the videos only let me record 15 minutes, but if you need to copy these definitions, feel free to pause the video at any time so you can get the definitions. The unit for pressure, the standard unit is called a Pascal, but there's actually several other different units. There's atmospheres, which is abbreviated ATM. A lot of people think that stands for atom, so make sure you don't confuse that with atom. Atmospheres is a unit of pressure. Then there's millimeters of mercury, and there's torr. These are all the standard units for pressure, so anytime you need to convert from one to another, these are all equal to each other. And these are in your reference packet as well, so you don't need to memorize them. So let's do just a few conversions. If we wanted to convert PSI to millimeters of mercury, you start with what you're given in the top left corner, and then since we need to cancel PSI, that comes down diagonal, and we're trying to turn it into mmHg. These two numbers are the standard units. So 760 millimeters of mercury is equal to 14.7 psi. And then you just have to do the calculation. So go ahead and pause this video and try the next ones by yourself and see what you can do. So you can see on the second one, we're going from torr to kPa, so bring your torr down. Put kPa on top, and then these numbers are the standard units. So 760 torr is equal to 101.3 kPa. For the next one you should have gotten about 131, and the last one is about 29.3. Atmospheric pressure is a little bit different. This is when we have all the gases in the atmosphere, the force of gravity from the center of the Earth, since the Earth is so big, it's pulling all of those gas particles towards the Earth. So the closer you are to Earth, the more pressure you have in terms of the gas particles. As you move away from the center of the Earth, the gravity decreases, which means the particles in the air can spread out. So you may have felt this if you ever fly on an airplane and your ears pop. It's because as you move higher into the atmosphere, there's fewer oxygen or any gas particles at all, and so your eardrum can detect that change in pressure. And we measure this pressure using a barometer. Bar means pressure, and meter means to measure. So it's an instrument that measures pressure. And go ahead and take a minute and copy down this chart and pause the video if you need to. This last word down here says motion. I know it got cut off on the screencast. The biggest mistake people make with this is they assume that solid is close together and liquid particles are farther apart. Notice that both of these have particles that are really close together. So solids and liquids, you really can't change how close they are to each other. It's gases that you can change that. So since gases are so far apart, you can compress them together. And here's just a picture. Notice the solid particles are just vibrating next to each other. The liquid particles are still slammed up next to each other, but they can flow around each other. So the difference between these two is that the liquid particles can flow, whereas the solid particles are kind of stuck in one place and just vibrating. And then notice that gases are very different. They're very far apart, and there's all this space in between them. The next word is equilibrium, which means that two things are happening simultaneously. So if you're doing a phase change at equilibrium, it means that each phase is happening forward and backwards at the same time. And we're going to do a whole lot with equilibrium in our next chapter, so for now just go ahead and jot that down. There are 6 phase changes that you need to know. So freezing is liquid to solid, melting is solid to liquid. Those two should be pretty familiar to you. Condensation is gas to liquid, and vaporization is liquid to gas. Those are probably also pretty familiar to you. And notice that vaporization has several other words you could use as well. Boiling is liquid to gas at a high temperature, and evaporation is liquid to gas at room temperature. These last 2 words you probably need to put a star by because you're probably not as familiar with them. Sublimation is solid directly to gas, so you completely skip over the liquid phase, but it doesn't happen very often in nature, so that's why you might not be familiar with it. And deposition is gas directly to solid. So what we're going to do is look at a phase diagram, which shows the relationship between pressure and temperature. And each substance in the whole world has its own phase diagram. So like water has a phase diagram that looks different from carbon dioxide. So this is what it looks like. It's always going to look kind of like a lowercase y, but the angle could be a little bit different. So the space over here on the left is always going to be solid. The space in the middle of the y is always liquid, and the space to the right is gas. So if you're in an open space, it's just one state of matter. The solid lines that separate the two, so this line right here that separates the solid and the liquid, this is where you could have either one. So 2 different phases could exist on this line. And as you cross over the line, it's a phase change. This one point right here in the middle is called the triple point, and that's where all 3 phases could exist. The other point you want to recognize is the critical point, and that's way over here on the right. This is the last point where you could still have a liquid. So at this point, the temperature is so hot that no matter what you do to press those liquid particles together, they're not going to make a liquid. It's going to be a gas no matter what. And the last one is normal. Anytime you see the word normal, you need to think standard pressure. So if I asked you for the normal melting point, this is the melting line right here. So every single point on this entire line is melting as long as you're going left to right. But if I say normal, then that means it's at standard pressure. So what you would do is go up to standard pressure, like for instance if it's torr you would go up to 760 and then go over to the melting line and see what temperature that is. So go ahead and pause the video and write down these definitions. The triple point is where you could have all 3 phases. The lines represent 2 phases. The critical point is that last temperature where you could still have a liquid. And then the most important one that people tend to forget is the normal. Anytime you see the word normal, I want you to circle that word and I want you to circle standard pressure. So normal happens when it's only at standard pressure. So here are 2 phase diagrams, one for water and one for carbon dioxide. And notice that carbon dioxide's triple point is way higher than water's, which is why it goes directly from solid to gas. And that's called sublimation. So the line on your notes, that bottom got cut off, it should say sublimation. The kinetic theory or the kinetic molecular theory is the idea that all particles are in motion, and we talked about that before as well. And again, I'm going kind of quickly through this, so feel free to pause it if you need to. Gases, we're going to focus on separately since they're so different from solids and liquids. So for gases, they have no shape or volume. because they're easily compressible. So if you take away the space between the particles, you can squeeze the gases together, or you can let them spread out. We've said that the particles are very far apart. These particles are not attracted to each other, but they also don't repel each other. So there's no attractive or repulsive forces between them. They move randomly at very high speeds. And they travel in straight lines unless they collide with something. And then the last thing is the kind of collisions they experience is called elastic collisions, which means that no net energy is lost. So once they collide, they still have the same energy that they had before. The next word is vapor pressure, and what this is, anytime you have a surface of liquid, so if you have a puddle or if you have a water bottle or something, on the top of that surface of the liquid, some of that liquid is evaporating, so you have a little pocket of gas sitting right on top of the liquid. That pocket of gas is called vapor pressure. So the more gas you have up here, the higher the vapor pressure. So it's basically a vapor sitting on top of a liquid. And if you heat up that liquid, it's going to make that vapor evaporate even faster, so the vapor pressure would increase. As temperature increases, vapor pressure also increases. The next vocab word is volatile, which just means that it evaporates easily. And the reason it evaporates easily is that it has weak bonds. Put a star by that word and make sure you knew that vocab word. And since it evaporates easily, it would have a high vapor pressure. So again, vapor pressure is that pocket of gas on top of the liquid. So if the volatile substance is evaporating quickly, you have a high number of gas particles sitting on top of the liquid, which means it has a high vapor pressure. Boiling point is when your vapor pressure equals the atmospheric pressure. And once you get to this point, I want you to circle normal and circle standard pressure. So if I ever ask you for the normal boiling point, this is the temperature where liquid turns to gas, but it has to be at standard pressure if I say normal. So again, anytime I say normal, think standard pressure. And if you press on the liquid, it can't boil as well, so that you'd have to heat it even more. So if you have higher pressure, the boiling point would increase. And since you have lower pressure at high altitudes, the boiling point drops. So instead of boiling at, say, 100 degrees Celsius, water would boil at 90 degrees Celsius, so it means you have to cook your food a little bit longer. At higher elevations, you have a lower pressure, which means it boils faster, but it's boiling at a cooler temperature. So that means you have to cook your food just a little bit longer. And the last thing is a vapor pressure diagram. So what this is showing is the liquid to gas line. So each of these lines represents the difference between a liquid and a gas. So if you're right here on the left of all three of them, right now A, B, and C are all liquids. As you cross over A becomes a gas, but B and C are still liquids. Then keep on going, and you cross over B, so now A and B are both gases, but C is still a liquid. Keep on going, and now once you get to the right of all three of them, they're all gases. So it shows how well they turn into a gas. So the first question says identify the normal boiling point. And again, normal, when you see that, you need to think standard pressure. So if you look at the graph, the unit for pressure is mmHg. Standard pressure for that unit is 760. So if you go up to 760 and over to each line and see what temperature it is, that would be your normal boiling point. Volatile means it evaporates easily. So if you start your pencil over on the left and start to go to the right, the first one that would evaporate is that first one, letter A. So that means it's the most volatile. Letter C over on the right is the least volatile because it takes the most temperature. You have to heat it the most to turn it into a gas. So the strongest forces of attraction would be C over here on the right because letter C, there it is, letter C over here, you have to heat it the most to get it to turn into a gas. Versus letter A has the weakest. And the last question says, how does the vapor pressure change as temperature increases? So as you move to the right and increase the temperature, notice that the vapor pressure also increases. And we talked about that if you increase the temperature of a liquid, you would have more gas particles on the surface of that liquid. So this is a direct relationship. The two worksheets that match up with this are the graphs on pages 1 and 2, so go ahead and try those two worksheets. And that's all for today.